basically run different type of cipher queries on Neo4j. We had done that through the Neo4j Sandbox, which is a cloud-based service offered by Neo4j for practicing as well as for doing real projects. Right. Today we'll see the desktop version of Neo4j, where you can install the Neo4j on our desktops, right, on our desktop or laptops, and then we can run applications. The same thing, I mean, similar to desktop, we can run it on a server, on cloud, on any other machine configurations, right? And then we can access it remotely. So then essentially we can use it the same way that I'll demonstrate you today for any large applications, right? So yesterday we were seeing how the Neo4j can be basically the Neo4j browser, right? How it can be browsed, the different nodes from the Neo4j browser, which is the default browser. There are other browsers also, other applications built around that, but Neo4j browser is the official one and the most popular one, where we can do some query-based browsing and visual browsing element. In fact, Neo4j provides certain mechanisms which we can use to create this kind of browsing mechanism on our web services also. Like if you want to build a website where you want to interactively browse upon nodes, etc., these kind of supports are also provided. Today we'll see like how we can use Neo4j from a Python, right? So from a Python script. So this will generalize to not only to Python script. There are other drivers like non-Python drivers like Java, JavaScript, etc. also. But we will focus on Python today, and we'll see how we can use Python script to create a Neo4j database from scratch, and then access it programmatically from the Python script only, right? So this will kind of unleash the power of Neo4j, how it can programmatically be used for our application development purpose, right? So is my screen okay? Now let me share my screen. Is my screen visible now? Can anybody confirm if my screen is visible?
Yes, sir, visible.
Okay, good. So I have installed the Neo4j desktop version. So you can find it from the Neo4j official website, right? Neo4j.com, and then there's a desktop version you can download and install. It supports all the usual operating systems, right? So I'm using it on a Mac. So once you install this, you can open the Neo4j desktop, which will open something like this. I think the example project will be there. These are some projects I have created. So what you need to do is, once you have installed this and opened this, you need to create a project. Project is, you just create a new project, it will create a project, and then you can name it. Like, let me name it something like, anything, any name you can give. Let's say AIFA project 2. Okay. So let's create a project. Now, project is kind of a, I mean, like a virtual name given to the activities that we'll be doing inside this graph database. Right? So this name really does not directly point to the database, etc. It's just a name given to all the work that we'll do inside that. And then within this project, you have to add a DBMS. So DBMS is the database management system. So we can add different type of local DBMS, remote connection, or we can have a DBMS file also. Remote connection is like we can add a DBMS which is remotely hosted. We'll do a local DBMS which will create the DBMS in our machine, right? Our local machine. And we have to give it a name and say a password, right? So I'll give you a name of AIFA DBMS. Let me give it a name, AIFA DBMS. So this is and we have to give a password. So I'm giving a password like my_password. So this password will be personal to you. Now since I'm using it from my laptop, you really cannot access it. But otherwise, if you are hosting it on a private cloud or something, you have to give it a strong password so that other cannot access this using programmatically from their machine. Right? So this name and the password, and then I create the DBMS. Once the DBMS is created, it will take a while just to create the DBMS. Yeah, then we can start it. Start means now this DBMS service will start running in my local machine, and it will show the port where it is running. So these are kind of services which uses Bolt protocol, right? So Bolt is a protocol like HTTP protocol. Anyway, you don't need to bother about the, you just start it, and then once you click on this, you'll see the Bolt port 7687. This is an important number. We can access it to HTTP or HTTPS as well, because when you will actually host in from a remote application, you can use HTTP port. Locally, you can use the Bolt port 7687 is the port number. This is what you need to remember. Right? And then once we have created this now DBMS is now running. So I just created it afresh. There is this did not exist earlier. Right? And the default database created is, so the under the DBMS, you can create multiple databases. So now database here corresponds to one connected graph. Now this connected graph database may have different type of nodes, different types of relationships, etc. Right? But one DBMS is like the several DBMS is like several disjoint graphs. So for example, if you, let's say you are creating an application where you are mining satellite data to kind of predict agricultural product harvest, right? So to do something like that, how you would have organized our data and in this Neo4j database? Say our project name would have been like harvesting prediction, something like that. Then maybe the satellite data, the raw data we are getting, we structure that in some way, and we want to put that into graph database. We'll create one DBMS, like the DBMS for our project. And under that, we'll create this one graph, which we will name something like raw structured raw data, right? Or I mean, pre-processed raw data, right? So pre-processing means there is some structure you can create a graph. Now, let's say you analyze this graph and you derive some intermediate information, right? Information which is useful for our prediction. So this kind of information you can keep in another graph, for example, another database. Graph and database here is anonym. I mean, like synonymous, right? So the database and so when we create another database, say processed data or prediction ready data or model data, something like that, we can keep that in the second database, which we can name like that. And so there will be two databases under the same DBMS. These two databases are completely disjoint. They don't have any connection with each other, the raw preprocessed data and the processed prediction ready data. But then, I mean, like our entire project holds one DBMS. Within that, there are two disjoint data, but within this database, there could be multiple connected nodes, different types of nodes and relationships among them. So these are connected within the database, within a graph, they are connected. So this is the overall structure. Now let's say Neo4j is the default one. I'll continue to use the default one. You see the number of nodes, relationship label, relationship type, property keys, all are 0 here. So basically the graph is empty. Now let's see how we can populate this database programmatically from our Python script. Okay. So I've written a small Python script here. So the driver we are using, so even for Python, Neo4j provides different several drivers, right? So it's not that Neo4j provides it. Like there are several driver applications built to use Neo4j, built by different agencies, different I mean, like academia also, different parts of academia, and also by Neo4j. I'm not using the Neo4j official one. I'm using Py2Neo, which is one of the most popular database, and it is popular basically the library to access Neo4j driver, right? So Py2Neo, I'm including certain things like the graph node relationship, graph service errors, and then what I'm doing here, I'm creating a driver. So this is the code for creating a driver. You see what I'm doing here. I'm giving this localhost. Since I'm running this in my local machine, this is localhost. You remember the Bolt port number that we discussed. This Bolt port number is 7687 that we are putting here. And then the default user, this is authentication. The authentication is the username and the password. The default username is Neo4j. I did not change it. You can change it from there is a configuration mechanism. There is a configuration file which once you install Neo4j, you'll get a configuration file in the installation area, and you can change that manually. But I did not do that. So the default username is Neo4j only. And the password I set while I created this new database, right? New DBMS. This password is my_password. So basically, if you make a mistake here, you will not be able to access the databases. Once since it is running, so basically it is running in this port. So basically this graph service is nothing but communicating as a client to this program which is running at 7687 baud port and trying to access that with the authentication of user ID and password. And then once we have the graph service, I can access any database within that using this graph service within, there's a dictionary under graph service, we can Python dictionary. So graph service within bracket Neo4j. This Neo4j is the name of the database, the default database. Right? So this is the graph. So we have a handle to the graph. Otherwise, there is some error conditions. So once we get the graph, for our, since I'm about to run this script multiple times, I put a delete all command. Initially, when you do create a graph, you don't need delete all. Delete all means the graph will be clean. Everything will be clean. Reset the graph. So no age and no relationship and no node will exist. Right? No entity relationship will exist. Now, once it is cleared, I'll try to do something. I'll try to create a node which is a dish type node. So I'm trying to create here a couple of type of nodes. Like one will be dish. This is like our food dish, right? And I'll give it a name. For example, I'm trying to create a dish which I call, the name is roti. So basically a node for roti. And how many percent this dish will serve? Let's say this will serve 4%. It's vague. I mean, it's not very, I mean, like it's vague, but you can put any attribute here. So these are the two attributes I'm giving to that node. You can give any number of attributes. So the two attributes I'm giving here is name and serves. Name is roti and serves is 4. So I'm trying to create this node. So there is nothing else. So this is def main and I'm running the main. That's it. This much is the script, right? So, and I'm printing the result data. So whatever result, this print is also even not important. So I'm just running, this is the demo.py script. I'm running demo.py script. So once I run it, no, this has to be restarted actually. I mean, before, for the first time connection, this has to be restarted. Otherwise, this doesn't work. Delete this one. This one is removed. This one is. You have to restart the Neo4j. First time you have to, once you create this, you have to restart the Neo4j. Subsequently, it will not be required. So I have the DBMS, starting it. This is the bold port, it is running. This is the database. Yeah, so it see the refresh was not working, but now it automatically came here, the 1.1 node, because the data was written, but this browser was not picking up. This GUI part was not picking up the insertion that I made from the script. Now that I restarted, it picked up this, and there's two properties. Now let us see. So this is the desktop version. This is not the browser version that we are seeing yesterday. So this is a desktop application altogether. Right. So here, if we want to now go and see the Neo4j browser, and once you come here, you have to go to this basically run this :dbs command and use, there are two, so by default this Neo4j and system, these two databases are created, right, automatically. I'm using the Neo4j for my insertion because if you remember the script, this is the Neo4j database that I'm using, right? This is the database name that I'm using. I can give it any name, then I have to create accordingly a table and set that to the default. Right? Now, once I'm here, I was opening the browser. So I'm using Neo4j, use Neo4j. Now you can run any command from here just to see whether match n, return n. Just like we were doing yesterday, see the roti node has been created. Right, so it was empty. Now the roti node has been created with the name and the source. These are the two attributes I had created from the application. Right. So this is as simple as that. We can create a node like this from Python script. Right, and there are multiple mechanisms by which we can create a node. Right. The easiest mechanism is just to write the cipher query as a string and call graph.run, right? It's the easiest mechanism, right? And this works. The other mechanisms are this Py2Neo, for example. In Py2Neo, we can write some APIs that is given by Py2Neo, where we can call like, okay, create a transaction. In the transaction, create a node with these attributes, etc. So it's a AP programmatic way. And this is a way where we just create a string. We can create the string programmatically or whatever. But if you can create the string and call run, this will run. So this is the second way to create a node. The third way to create a node, or we should say rather include a node or import a node, is we can have a CSV. Let's say we have a data set which comes in a CSV file, right? And in the CSV file, we can directly import into the Neo4j database by using a command which is given by Neo4j cipher query itself. Right? So I think the command is load CSV. Just like create, we have to use load CSV. And load CSV has certain, things which you have to write here. So certain parts you have to write here. Then you can load the CSV as well. Okay, so directly all the entries of the CSV, the rows will be transferred to as each row will become a node, and then the entire CSV will be imported. That way, right? So these are the multiple mechanisms by which we can create a node in the programmatically in the database. Now let me create another node. So I'll save this and I'll run this again. Now since I'm delete all, I'm running it again and again. I'm deleting every time and basically creating every time, right? Ideally, you will not do that. Ideally, you will not delete it and you will not create. Basically, you will not delete it and you will not run the disk insertion again. Because when you have an interactive application, let's say, the application is always running, right? So you will not create the node and run like I'm running every time. So what you will do is like first time somebody created, let's say user created this, right? Then another user will come create something else, and it will keep on working like that. The program will keep on running and the nodes will keep on getting added. Right? Here, just for demonstration, I am deleting every time and creating both the nodes. I mean, like whatever I'm doing afresh every time at every run of the script. So if I now run this again, see though both the nodes have come, right? Now ATA is the name ATA and its ID is 2. So ID is automatically assigned. You see that there is a unique ID. This ID is the primary key unique identifier in the database for this particular node. So all the nodes will have a unique ID. Yes, any question? Any question so far? Okay. So going to the script, now we want to create a relationship between the two nodes that we just created, right? One is the roti and another is the ATA. Right now, if we double click on roti, nothing happens. If we double click on nothing happens, only the properties are shown here. So now let me try to create a relationship between these two nodes, right? So how will I create a relationship? Basically, we need a handle to both the nodes that we want to create a relationship between, right? And then create the relationship. So how we do that is match d:dish name roti. So basically, we are trying to match a node where the name is roti. We can match by ID or any other attribute for that matter. As long as it is unique, it should work, uniquely identified. So D is name of that matched node, basically the variable name. Right? Then we have another match where we say that okay, I is the name of an item whose name is ATA. So match that also. So here we are using two matches consecutively. I remember yesterday someone was asking if there are 3 edges on a particular node, how do we create a matching, basically find the pattern, right? Because we are seeing that there is a dash-based, the ASCII character-based singular line, single line kind of queries we are writing. But you can write queries with, this is, I was trying to explain yesterday, for the syntax yesterday. So the syntax is basically, you can write a match, then put a comma, you can write another match, and you can name each match as a variable. For example, D is a variable, I is a variable. Then you can write something on top of that match, D and I, right? So now you can imagine, like if a node has 3 different edges, you can match the first edge, you can match the second edge, then you can, and this within bracket, this need not be only a node, this can be a pattern itself. This can be a pattern where a node and the edge and a node and the edge and a node, like that, a long pattern like that. Then you match the entire thing, you match another pattern, right? And then you try to figure out some less, basically try to impose some more additional constraints on these two patterns that has matched. You do that by a where clause after that, like where d dot something has something to do, I mean, like something similar with I dot something, or something dissimilar with I dot something, some relation between d and I, right? So you can have a match like this, and it need not be only d, it can be like a b c d e, like 5 nodes conjoined by their internal relationships, right? A long chain of nodes and edges, right? So match that. Similarly, a long chain of nodes and edges match here, and all the variables we get here, all the variables we get here, we can create relationships using the where clause after this, right? And that can match pretty much like that generalizes to matching any kind of pattern that we want to figure out in the database. So here what we are doing, we are just matching one node in each of these match commands, and then trying to create a edge between them. And the edge is like from D, so D is the variable name, I is the variable name, and see that ASCII style this thing has come. Like D is the variable name, I is the variable name, and here we are creating a unidirectional edge where I'm saying that this dish D is made of how much of atta? Like 300 gram of atta. How do I specify? So this 300, so dish D is made of atta. So roti is made of atta. This is what I'm trying to specify here. Now roti is made of atta, then relationship name is made of. But the thing is, how do I specify how much of atta is required to make roti for which serves 4 people? So there I write something like 300 grams. So OS is an attribute on that relationship edge, and I put 300 gram on top of on that as a value of that weight, right? So on that relationship attribute. So this is the relationship I am trying to create. For the relationship variable name is R. Again, R is not required in this query. I can remove R; it will pretty much work. But the relationship name is made of, and it has an attribute OS, which has value 300 gram, right? So if I run this query now, of course you can. Sorry. Right. So if I now run this tool, as I said, like I was just trying to match all the nodes, and this browser has a intelligent behavior that if 2 nodes are present which are connected by a edge, it will automatically show that edge. Otherwise, this query by itself, when you do a programmatic query like this using, let's say, the Python script, like you will not get the edge. You will get this return value as like 2 dishes. Like one is the dish, sorry, 2 nodes. One is the dish node, which is for roti, and there is the item node, which is for atta. You will get only these 2 as the return value of that. Right? You will not get the entire this relationship. But this browser has this intelligent behavior which shows the this thing. And if you click on the relationship, you'll see this OS attribute has come, which is 300 gram. Having shown this, like now that we can create a graph from scratch, graph database from scratch, and we can create the node and relationship, we can create attributes on the nodes, we can create attributes on the relationships, and we can put direction to the relationship. So this means that now we have the power to programmatically create any graph. So will you agree to that? So now this simple demonstration up to this point, we can say that now we have the power to read any database from, let's say, CSV, any kind of other database, and put that database into Nov21. Only this much demonstration is required for that. Do you agree? Anybody who has a doubt or does not agree to this statement?
Sir, can you explain once how the 3 nodes can be connected to a single node by that edge?
No, in the query you are saying?
Yes, sir. Like in previous day, there was a question that how to connect.
Right. So see, this is one pattern. So what we are trying to matches pattern, right? This match command, match clause, it matches patterns. So this is matching one pattern. This is matching another pattern. So we can match any number of patterns. Since we can put commas in between, we can match n number of patterns like this, right? Now let's say we can do something like D dish, which has a name roti. Let's say we are not trying to create, we're just trying to match a pattern. That's what your question is, right? So
Yes, sir.
right. So let's say this roti dish, then we say that it is made of is, so relationship is made of uh, some name is let's say atta, right? This is the relationship that we want to build. Is made of is made of is the ways, right? Ways is the property. Ways 300 gram. 300 gram. Then let's say we make uh, another type of node. I'm assuming we'll have another type of node, which is let's say can be purchased at, right? Something like uh, P. So which is shop. Is no roti is made of atta. Let me first do that pattern. Complete that pattern. Roti is made of atta. So this is one pattern. So up to this much, it is good, right? Roti is made of atta is the pattern we're trying to match, right? This is one pattern which matches roti is made of atta. So it matches two nodes, basically two nodes and one relationship. The first node has name roti. The second node is of type item, which is atta. Name is atta, and the relationship is this is made of this. Right? So we find this pattern in the graph. Now we want to find like where atta can be purchased, let's say. Right? So we can write another pattern like this, where uh, name atta. So let's say we assume we have another type of relationship in the graph where E can be purchased. Can be purchased at. Can be purchased at. Then shop name. Let's say shop name is something like more. So we put something like this. Okay. And can be purchased at more. Can be purchased now. Can be purchased as shop name more would be the node. Sorry, this is can be purchased at, then another node which is shop is colon shop name more. This is right. This is right. So this much can be purchased at. This bracket will not be there. Now this is another pattern. Do you agree to this? So we are trying to match two patterns. One is roti is made of atta. Then atta can be purchased at more. So we have three types of nodes here. One is dish, one is item, another is shop, right? And we have two types of relationships which are shown here. Is made of and can be purchased at, right?
Yes, sir. Clear.
Now is it clear? Like two patterns are there. Now you can write a where clause here, like where I mean like now you can have another thing like where let's say some clause sorry, some condition, some attribute which relates let's say roti to the shop, or a dish to the shop, or dish to the another relation of item to the shop, right? Another kind of pattern of item to the shop, or any other third kind of node. You can put another comma and match that pattern also. If you match these three patterns, let's say you match another pattern, then you say where d dot, let's say d is the dish name, d dot some attribute, so let's say attr1, which can be name, let's say d dot name is not equal to let's say there is another, in this pattern we have matched a node e, right? Matched a node e dot value, the e dot name not equal to e dot name, something like this. So and you can create this RB, and this is a boolean I mean like expression you can create. You can say and these or these. You can write anything like this in the where clause. This can create pretty much any relationship among the matched patterns, right? So now do you follow like how multiple like patterns can be matched and their relationship can be established?
Yes, sir, it is clear now.
Okay. So let me put this in comment. Now that we can create a graph, okay. So I'm assuming that you understand that now you can have pretty much you can create any such nodes from your whatever data you have. Let's say you have data of like image data, etc. I mean any kind of data you can keep. But typically Neo4j or graph databases, there is a recommendation that do not create a blob. Do you know what is a blob? So a blob is like bulk of data. For example, large text file, the entire file itself can be treated as a blob, or an image itself can be treated as a blob, right? Or it's a video or an audio recording. All these are blobs. So these are not kind of textual or ASCII kind of data which we can put, or even not even binary data. These are like these are binary data, but the problem is there is a bulk of data which you want to keep as a value of a particular field or against a particular attribute. So the recommendation of the graph databases are do not keep blobs inside the database. Rather, you should keep a pointer to the blob. So what does it mean is that let's say you want to store images in Neo4j. It's better not to put the entire images binary as the value of some field, right? It's better not to do that. Better is to like keep the image uploaded somewhere and keep a pointer of that, maybe the URL or something at the to point to it, right? So for example, you can keep the image or the video, etc. Uh, in a cloud like AWS S3 buckets, etc. And then you can have a pointer to that S3 bucket and put that in the database so that you can have a unique mechanism to access the particular image, but do not keep the image itself in the space of the graph database because it makes it somewhat inefficient, right? So this is kind of a small hitch that it comes with. So now after this is created, let's say now I'll show something interesting, like I'll show you how we can create very complex queries, right? And now work on this data that we can create using these commands. So I'll close this file because this file was just to demonstrate you like how we can programmatically create nodes and uh, uh, relationships in a graph so that we can create, from scratch, we can create Neo4j graphs. Right? Now, assume that I have a Excel file. So I'll quickly show you this data set. Right? Yeah. So I have an Excel file. This is the data set I have. This is an unpublished data set, by the way, which we are working on. So this is a data set of dishes where the dish this is a data set of Bengali dishes where there's a dish name. The names are some Bengali names which are written in English. As an information source, the scraping time, we scraped it from the internet. So scraping time, how many people it serves, what are the ingredients, how much of ingredient is required to prepare the dish, whether the dish is, what type of dish it is, breakfast, lunch, snacks, dinner, starter, main, size, dessert, etc. Then we have an item where we see the different kind of items that are used to prepare the dish. It's alcohol, almond, aloo, apple. So all the different kind of ingredients that are used to make the dish and kind of a measurement of the ingredients. Like one cup of alcohol, for example, is 215 grams. So these are some measured weights of this particular unit. So 1 teaspoon of atta is 2.5 grams. 1 tablespoon of atta is 7 grams. So some weight conversions of the items here, right? And then we have a combination like there are so let's say we have certain dishes and we want to have how this dish goes with the other dish, right? So these are the combination values. Like 5 is the best combination, 0 is the worst combination. So any dish does not combine it itself. So this kind of a database which you want to basically which we'll have in Neo4j and we'll want to run certain queries. So I want to show you like what kind of interesting queries can come out of this. Right? So let's say we have this database and we have populated the database in our Neo4j. So I need to stop this. So the database is imported already. So I will stop this and I will go to the, what is that? Browser is not required. Projects, and stop this one. This is not running. So I'll start this PyDB where all these database, the Excel file that I showed you, those points are, those nodes are added, nodes and relationships are added. So, right. So now we have this. If we go to the browser now. The browser, we have this one, DBS. We'll use the DB. In the DB, so dish. So these are the different, I think, how many dishes? 384. Many, so practically many dishes and their internal relationships. And this is a funny behavior exhibited by the browser. If you try to move something, it tries to create a gap between two nodes based on how far they are in the space, right? So there is a meaning of the length of these edges also in this browser. So if two edges are close, there is some proximity it calculates, right? Some value proximity it calculates. So to place the nodes. Right? So, but let's not go into that. These are the different dish nodes. These are the different item nodes like bin broad, asphodida, Bashan, right? So these are all the nodes that were present in that item sheet. If we select on the one of these nodes, let's say we select on bin, you'll see that one piece of medium bin is 14, medium size bin is 14 grams, right? So this is the data that we have at this item node. Right? For example, if we have, let's say, alcohol, this is only carb. No, I want something where there is pin broad. Yeah. So we have this name gram. See this hyacinth green. There are two attributes here, three attributes. One is gram, one is piece medium. So basically 1 gram of hyacinth bean is 1 gram. This is a trivial information. So one piece medium hyacinth bean is 20 grams. So these are the kind of information that we have. If we click on the nodes here, sorry, these nodes here. So let's say Sada Bhat is plain rice. In Bengali, it is called Sada Bhat. So if we click on plain rice, we'll see that there are all the attributes here. Like this is DCID 18. There is some info collection time, info sources, home experiment. I did this experiment of home to populate, create the data. Is it? It's not a breakfast dish, not a dessert dish. It's a dinner, lunch, and dinner and lunch. People used to take rice. It's a main course. I mean, in the basically in the main dish, not main course. It's the main dish. It's not a side dish, snacks or starter, right? And weight per serving, typical weight per serving of rice is some grams, right? So these are all the attributes that we know have. Now I want to show you how we can create applications surrounding this much data we have. Right? Now let's say so don't look at all this code. All this code are for population and etc. So I want to directly get you to the query part, right? So here I am basically again the same thing that we did in the small demonstration where I showed you like how to connect to the database, etc. So these are the password, etc. I mean the author, the URL, username, password. After that, we connected to that server. The same code that I had shown you. Only this time these codes had some wrapper. So don't look into that. That simple code will work. And then we did some queries. Now the queries, what I did is like. I mean, like, see the query, I'm trying to create the query as a string, right? Now the string can have many varieties. For example, I have created a function here, which I give certain properties. Like I want to find a node where I want to find 4 nodes. So this query is like, it's a function I have created. where the query string is getting generated based on certain parameters, right? The parameters I'm seeing is that, so I want to find 4 nodes in the graph which are cliques. I mean, which together form a clique. So do you know what is a clique? Can anyone say what is a clique in a graph? Anyone? The clique in a graph is a let's say it's a 3-element clique. Means there are 3 elements, basically sub nodes in the 3 nodes in the graph which are all connected to each other. So all the NC2 connections possible exist for these 3 nodes. So 3 C2 connections exist. A 4 size clique is like 4 C2 connections exist between all these nodes. So all these 4 nodes are everyone is connected to everyone, and this becomes a small subgraph within that graph. So so there are popular algorithms for like finding a clique in a graph, etc. Like I mean, like heuristic based, etc. But the idea is that a clique is like a very strongly connected subgraph. In fact, fully connected subgraph within a graph. Right? And max clique means the maximum size clique. So let's say within a graph, I want to say find the max clique. So you have to, let's say the graph has 50 nodes. Maybe 2 nodes are always connected. Two sides clique is obvious if there exists at least one relationship, right? Because these 2 nodes are connected to each other. 3 sides clique is possible if there is a triangle exists in this graph. Right? Now 4 sides clique is like a quadrilateral with all 4 corners connected, right? Along with all the edges. Now, like this, if we go on, what is the largest clique that we can find? So that is a kind of a max clique. Since a max clique is a very popular problem, it has applications in many different domains. Right? So here I'm trying to find a clique of size 4 in this disk graph, where I'm saying that the mill type, basically, first disk should be a lunge disk, second disk should be a lunge disk, third disk should be a lunge disk, fourth disk should also be a lunge disk. Similarly, I'm saying that disk type, the first disk should be a main. So basically, I'm trying to figure out a mill plan for 4 mill plan of 4 dishes, where all these 4 dishes are lunch dishes. So basically mill plan for lunch. So because the mill type is all 4 dishes are of lunch type. Then I'm saying the first dish is a main, second and third dish are sides, and fourth dish is a dessert. So it's kind of the completes the palette you want to get in the mill. Right? So main, 2 sides and 1 dessert. And then I'm saying these dishes should have a combination value that how this goes well with the other dish. That value is minimum value should be 4. So it should combine very well. Each dish should combine with other dishes very well. And maximum combination value you can find is 5. So 4 to 5. So because 5 is the best combination value, I'm saying that 4 to 5 is a allowed range. So each dish should combine with other dish with a high combination value of 4 or 5. Okay. And how many results we want to see? We want to see 3 such mill plans. Okay. 3 such mill plans. So I created a function like this. And what I'm doing is simply like converting all these things into a Cypher query. Right? So if we go into this function, I'm getting all these parameters. And based on this parameter, I'm just creating a string. And the string is of the Cypher query. So if these are the inputs, for example, the Cypher query generated is this. So the Cypher query generated means the string is generated. The Cypher query string is generated. So I'm saying that if this first parameter is lunch in the mill type, the is lunch attribute should be 1 in this query. If the second parameter is lunch, the second is lunch will be 1. Third is lunch will be 1. And then I'm saying that, okay, now, and this is saying that, okay, the combination value, you see the minimum combination value and maximum combination value you have given. So what I'm writing here is that dish B0, this is matching a pattern unknown, combines with, so combines with is a relationship in the graph, another dish D1, okay, and the combines with relationship, we are giving a name C0, where C0 dot combination value, combi value is the attribute on that one. So C0 dot combination value should be greater than 4 and less than equal to 5. So because we have given the minimum and maximum 4 and 5. So you can see, you can play around with these parameters and you can create parameters as you like, and you can create a variety of strings automatically just by switching the parameters, right? You have to write this logic only once and you create an entire application around that. So this function, it's essentially creating an application mechanism which can be customized to your liking, right? And it will give us a result like this. So let me run and show you how the result comes out. see, I have run 3 queries. The first query was this cipher get this click. This is the query which is generated from this this part, right? This is the query which is generated by calling. So after I populated the database, then this is the query I have run by calling that function with some values like click size is 4, the 4 meal types, 4 meals will be lunch, main side said dessert. So if we run this query and then I'm just printing the result. So this name list, so this cipher query here returns some lists, right? And if we process the list and print out the dish names, these are the outputs. So if you so the output here is like the main dish is sada bhat, which is plain rice. Then there is two side dishes, right? Two vegetables basically. One is egg curry, and then fourth is chutney, right? So now Bengalis can appreciate, Bengalis in the class can appreciate this is a good plan in fact, right? So you see, just by getting some data and manufacturing this kind of query, I can get a very interesting answers from the database, right? So this is just getting a click. You can write applications like this by just creating a function like I created here for getting a click. You can write a function for creating any kind of graph applications, right? And by generating this query, this is the string query which I generate from that function, right? Using these parameters. If you generate this and run this, you can get a application around that. Let's say I run the second query is another click where it's a 3 stage, so basically 3 dish click, where the first is breakfast, second is lunch, third is lunch. Okay, so here you'll see that I get like first dish has to qualify for. So basically this is kind of application which was trying to see if a breakfast main dish can be combined with 2 side dishes in which goes well in lunch. So for example, if I have something for breakfast and if I some main item in breakfast which is excess, right? Let's say I am planning for a meal, but then I see that okay, in my breakfast I have this element excess. I mean, kuch bach gaya, right? I mean, something is left over. Can I use that to plan my lunch also, right? So this is a query for that. So basically, the first item is suitable for breakfast, and then the second and third items are suitable for lunch, and second and third items are side dish, first item is main. If I run this query, you will see that people usually take breakfast as roti as breakfast as well. So this has come as in Bengal it is called roti. So I have written roti here. So roti and 2 side dishes which goes well. So this roti qualifies for a breakfast main dish, and these 2 are side dishes. So this is another application you can see. Just by changing the parameters, I get another kind of application on that. Right? Another kind of query. Third is, let's say, here I'm trying to find all sweet or potato major dishes. Like, or find all the dishes where either it is very sweet or there are a lot of potatoes. So basically, I'm trying to find out which dishes are not suitable for diabetic people. Let's say. And I created another function for that. Just like I created a function for getting a click. Here it's a function like get dish with given items. So this query is like I'll give some item names. It will find a dish from that. So essentially, this query is another function I have written, and there are certain parameters like the previous one, right? So I am passing the meal type, dish type, what are the item names, etc. Minimum, I mean, like whether the item that I am passing, like for example, here this API takes the item names that are to be present. Here I am passing 2 item names. I am saying that the meal type doesn't matter. So where this item has to be searched, I mean, which dish item has to be searched doesn't matter. This type also doesn't matter. It can be main dish, side dish, doesn't matter. But the item name is sugar. The minimum weight of this item to be present in is 10 grams. So basically 10 grams has to be present in 100 grams of the dish. Right? 10 grams of sugar has to be present in 100 grams of the dish. Maximum weight is none. So minimum, if it is greater than 10, it is a sweet dish. Right? So 10% of the dish is sugar, then it is a sweet dish. That's my definition. So minimum is 10, maximum is none. And so it is per serving. Okay, so this 10 is like per serving or per 100 grams. So I have given is per serving as true, which means that this 10 grams is not necessarily 10 grams means that this 10 grams is not in 100 grams, but let's say one serving of this dish, maybe 200 grams. Within that, if there is 10 gram of sugar, then this is a high amount of sugar. So this 10 value is essentially pointing to how much of per serving of this dish has this item, like of a dish has this item sugar. So that is the this last parameter. Then I put another item, say all the similar parameters, but here instead of saying that per serving, I'm saying that no, it is false, means it is per 100 grams. So if per 100 gram of a dish has 50 gram of potato, then it is a high potato. I mean, basically, potato major dish, right? So I named these two dishes, two items. So I want to find all the dishes that matches with these two, that basically is made of these two, one of these two ingredients. And since I say one of these two, this is a parameter for that. I say that all items to be present or one item to be present. If it is all item to be present, that means both the items has to be present. And then how this translates into the query. So basically, this creates. So if these are the parameters I create, so this, or if you see the where clause, so basically here I'm trying to match a dish as ingredient as item, and this is to be matched for every item. So I match for a dish has ingredient item where item's name could be sugar or item's name could be potato. So in where clause I have put this, right? The attribute names of the item that have to be matched. And this or comes because I want to match any of these. If I wanted to match all of these, like a dish where potato is also high and sugar is also high, I would have put or. In that case, our all items to be present would have been true. Then in that case, it would have been and, right? So this is then how many such dishes I want is like I want only one such dish where this thing is there. Right? So this is the cipher query. Now you can see, like, if I run this cipher query, if I call this program, it is generating. You'll appreciate this result also, like mango pudding, mishti doi, tiramisu, then homemade white bread. All these are high sugar and high calorie items. You can quickly figure out using this query. Right? So basically, these are not suitable for, we can say, for diabetic people. Right? So all these sweet names automatically came out by this mechanism. Right? So now I think you can appreciate like how when we can get the programmatic access to Neo4j, right? How we can generate several different kind of cipher queries based on our requirement, and we can create applications around that as long as we have a good information rich data set, right? Database elements inside that, and we can create any such cipher query. Like, any cipher query, you can just directly, instead of calling this generating through this function, you can directly run, like I was showing, like the run command in this code, right? You can directly for graph.run, then any query, you can write that query. I was just generating this query programmatically using different configurations. That's why this complication came. Otherwise, you can just simply write any query, it will work. Just to demonstrate it. So I think the last query I was trying to find all the chicken dishes. So where there is a chicken, and you will see that all the chicken dishes came out. So now you can understand like what is the power. So you think of your application, your area, your data set, and you can think like how all these, and if there was no Neo4j or cipher query is not there, you would know that for writing each of these programs, you would have to write some several hundred lines of code, right, to find out each of these pattern, to match each of these, etc. But all these kind of got simplified just by directly be able to query the Neo4j graph database. So that's why I was yesterday emphasizing on the point that if you can convert your data set into a graph database, then many different applications you can build on that graph database very easily, rather than doing the processing the Excel file or the data set each time. So I think I'm done today. So any question or comments or anything from the students? Anyone? Okay, so if there are no questions, we can stop the meeting today then. Thank you then. Thank you everyone.
Thank you, sir. you, sir.
Thank you.